So light year is basically, it is one of the units of length, just like meter, centimeter, inches, yards. Light year is also one of the units of length, but it is not the SI unit. Can you tell me the SI unit of length?
SI unit of length is meter.
Good, it's meter. But since we are dealing with light year here, it's a non-SI unit, and the symbol of light year is Ly, and we can define it as the distance traveled by light in 1 year. The distance traveled by light in 1 year is called light year. You must remember the basic distance formula. S is equals to Vt. You had also studied in class 9th.
Yes.
So since we know that it is a distance, we can always calculate this distance traveled by light. We know that light travels with with a specific speed, and that speed is basically 3 multiplied 10 raised to power 8 meter per second. You should remember this value as well, because whenever this question comes, they will not give the value of speed of light. You have to remember it.
Okay.
Moreover, since we are mentioning that it is the distance traveled by light in 1 year, and when it comes to 1 year, we know that year is not the SI unit of time, right? The SI unit of
Yes.
time is second. So we have to convert this year into second as well. In order to do that, we have to convert year into second step by step. We know that in 1 year, how many days are there?
356.
65. Okay.
Oh, sorry. 65.
And what about the hours in 1 day?
24 hours.
24 hours. And in 1 hour, we have how many minutes?
60 minutes.
60 minutes. And how many seconds in 1 minute?
60 seconds.
60 seconds. Can you multiply all of this? We will get a
Yes.
value.
Okay. The answer is 9.4608 multiplied by 10 raised to power 15.
Good. So this is the distance traveled by light in 1 year. So when the question comes in exam, you have to do this proper calculation as well. This would create a very impressive impact on the examiner, that the student has calculated it practically by steps. You can see that in the book, he has not solved it. He has just given the value directly, which is 9.4607 in line number 2. You can see that value, right?
Yes.
Page 9, light year second
Yes,
line. So we
yes, I
have,
did.
yes, we have calculated this value. Now he is explaining it a bit as well. He says, for example, spiral galaxies like our own Milky Way. There are basically many galaxies in the universe, and galaxy is such a big thing that this Earth, many planets like this Earth can be fit into one galaxy. Our galaxy is known as Milky Way. So he says that spiral galaxies like Milky Way measure approximately 2 multiplied 10 raised to power 5 light years in diameter. He is saying that the diameter of galaxies are 2 multiplied 10 raised to power 5, which means you have to multiply this value by 2 multiplied 10 raised to power 5. This is very, very big value. We cannot imagine this. So basically he's trying to explain us that this universe is very big. It is extremely large. It is huge. He says again, our nearest neighbor galaxy is the great spiral galaxy Andromeda, which has been determined to approximately 2.5 million light years away. Now, again, this is a gigantic value and it cannot be measured. So, this is how we deal with light years. In one light year, we have got this much meters. Okay.
Okay.
So you have to learn these this explanation. You have to write this along with this calculation as well when the question comes in the exam. The next one is
Okay, sir.
angstrom. Is it clear? Anything you want to ask?
Yes, sir.
Okay. Angstrom. Angstrom is again one of the lengths of the unit, one of the units of the length. It is basically equals to 10 raised to power minus 10 meters. Now this is a very small unit of length. You can see this actually means that just one part of 3, 4, 5, 6, 7, 8, 9, 10. This is a very big value, but just one part of this big value is equal to 1 angstrom. So it is a small value, and again it is a non-SI unit of length. Now where can it be applied? It is applied in the atoms. We know that atoms are very, very small. He is actually referring to the practical things we see in our life. In the light year, he mentioned galaxies because galaxies are the biggest things we can imagine in our mind. And when it comes to angstrom, he is referring to atoms. Again, atoms are so small that we cannot even see with our naked eye. Not even electron, not even proton, not even atom. We can't see them. So, because they are too small and their values are in angstroms. For example, if he's saying about helium, he says that the helium has a diameter of 10 raised to power minus 10 meter. I mean, it is 1 angstrom. So, it is too small. Moreover, the nucleus is 1 femtometer. Femto is again another unit of length and it is even more smaller than this angstrom. Femto is basically 10 raised to power minus 15. You might be very clear about this that whenever we have a negative power, the value is small, right? If this
Yes.
value was, if this power was positive, it would have been a very large value. Is that thing clear to you or should I explain it a bit?
That's clear, sir.
Okay. So this was angstrom. And the next one is micron. Micron is basically another uh, small unit. Micron is another name for micro basically. Micron means 10 raised to power minus 6 meter. Again, it's a small value. And when it comes to example, he says that red blood cells are approximately 10 microns in diameter. The red blood cells we have in our human body, their diameter is 10 microns. And as far as human hair is concerned, its diameter lies in between 10 and 100 micron. So these are very small values on a very small scale. These three were the units of length on different scales: micro scale, angstrom scale, and light year. So is that clear to you?
Yes, sir.
The question can come that explain light year, or can you calculate how much is the value of light year in meters? So we have already done that. Even if he does not ask, you will have to do that. You will have to do that. Okay.
Okay.
You must write those steps in your answer, even if it is not asked. Moreover, angstrom and micron. There is no calculation. You can just write whatever is written on the book.
Okay.
Okay, so the next one is writing units, symbols, and names. It is not very much important topic, but I can give you just a short introduction, or you can say I will summarize it in such a way that whenever there is a unit which has two alphabets, for example, if I write a unit Newton meter, remember you have to write the first letter of that unit with the capital alphabet followed by small one. Okay, you
Okay.
cannot write both of them as capital. This would become wrong. This is the rule. Similarly, if there is a single unit, it can be either small or capital depending upon the scientist who has defined the unit. So whatever you see, whatever you write, either it's small or capital depending upon the quantity. Moreover, if we have two prefix, do you know prefixes? What are prefixes?
Yes.
Okay, we have already discussed those like micro, nano. Okay, all these are prefixes. So he says that you cannot write two prefixes in combined form like micro nanometer with a unit. This is wrong. You have to join them like this. You have to first of all convert them into values. Micro stands for -6, nano stands for -9. Then you can add them. It would become 10 raised to power -15 meter. Then you can write it as femtometer because this is the value for femto. Femto is also one of the prefixes you have already studied in class ninth. There was a table on the right hand side of the page in which the prefixes are mentioned starting from atto, femto, pico, nano, micro, milli, centi, deci, deca, kilo, mega, giga, tera, peta, and exa. They start from minus and they reach up to the highest power in the form of positive 10 is power 18. So these are the prefixes. So he says that you cannot write prefixes in combined form. You cannot write more than one prefixes with a unit. You can't do this like kilo nanometer. This would become wrong. You can either write kilometer or nanometer or picometer. Whatever you write, you just need to write only one prefix with a unit. Got it?
Yes.
Are you clear with this point?
Yes. It is clear. Yeah.
Moreover, he says that if the unit of second time is second and the symbol for second is small s, you cannot write SEC in place of S. You just have to write S if it is S. You cannot um, change the form of the unit. Okay. I mean, you cannot change the alphabets. Like, for example, you want to write time is equals to 5 seconds. You should not write like this. You should write like this. Although the examiner does not deduct marks for these, but it is one of the rules. So I just wanted to tell you that they should, especially when you are writing two units. For example, if I write meter per second, you should never write like this. This would become completely wrong. You have to write like this, ms minus 1. Are you getting it?
Yes. Yes.
the next topic is errors, page 10. Or is it enough? Do you want me to continue or is it enough for physics?
I don't have any problems if we continued or if we start another.
Okay, then we can do this. It's not that much big topic. We will just cover the definition followed by its types. Error is basically, but you have to make sure that whatever we study, you have to cover it daily, right? Because it's
Yes.
important to follow whatever we study daily regularly, because if it is not being followed, a pile would become pending at the end of the year, and this will make things difficult for you. So
Okay.
please try to make sure that whatever we study in the class, you cover it daily, on daily basis. Okay.
Okay.
So error is basically doubt in any reading. It may be in different forms, and the reason can be different as well. It can be either human mistake, it can be mistake of the method being used, or it can be any fault in the apparatus as well. For example, if someone is calculating the BP of a patient, now if he is a fresh person and he is not very much aware of the device which we call sphygmomanometer, and he does not know how to measure BP, then if he does an error, obviously that error would be due to the lack of the knowledge of that person. It can be due to lack of knowledge, or lack of experience, or maybe carelessness. So that error is known as personal error, because it is concerned with the person who is doing that experiment. Okay.
Okay.
And when we talk about a device, for example, if a person who is experienced enough to measure the blood pressure of a patient, he is a very specialized doctor and he measures the BP as 120 by 80 mmHg for a patient. After attempting again, he gets the value 160 by 80. In the third attempt, he gets 90 by 80. Now you can see there is a huge difference. Now this is very clear that there is some issue in the device. The person who is doctor, he is doing the same procedure in all the three attempts, but unfortunately the value is not as same as it should be. There is a large difference in those values. It is understandable if there was an difference of maybe 1, 2, or 3 digits, but a difference of 30 to 50 digits is a hell of a difference, and it cannot be tolerated when it comes to measurements in physics. So it is clear that the device has some issue and there is a fault in the device. So we call that error as systematic error. And you can see the first type is labeled as systematic error. He says the systematic errors are those errors that tend to be in one direction, either positive or negative. Now he is explaining it in detail. Instrumental error. Instrument, as the name suggests, he says it arises from errors due to imperfect design or the calibration of the measuring instrument. He says that the device might not be designed so much perfectly that it can give consistent values which are close enough on repeating the experiment again and again. Are you getting my point?
Yes, sir.
Moreover, calibration is also not done. Calibration is basically calibration is a phenomena in which a device is overhauled or recycled again and again. Now, if we talk about calibration in our daily life, we can refer to the car or a motorbike. We go to the workshop and we do its tuning. In the tuning procedure, the workshop mechanic, what he does, he opens the overall vehicle. The spare parts are cleaned enough with the help of some chemicals so that it is ensured no rusting is there, nothing is working improperly, all things are in place, and the device or the machine is working properly. This is basically calibration, that you are checking whether the instrument is working properly. You are checking the entire machine part by part. You are checking the working of each spare part, and you are ensuring that whether the entire machine is in place, it is in order or not. So this is known as calibration. In a laboratory, when we talk about a physics laboratory, we have different devices like galvanometer, we have um, a prism, we have anything, voltmeter, we have ohm meter, we have oscilloscope. All these devices must be calibrated. Now, how that calibration takes place? It takes place in such a way that the device is opened overall and each spare part is cleaned, and it is ensured that all the parts are in place and they are working properly. They are getting the energy by the cell or the power supply, and they are doing the work enough. So this is basically calibration. So if a device is not calibrated after a specific interval of time, it would not give you proper values. It will create issues for you. As I told you an example of vehicle like car or motorbike, if a person is using a car for almost 1 year and he has not gone to a workshop even once in a year, the are you sure that the car will work properly? No. Obviously, there will be issues. Maybe the device will start working improperly. Its engine may not work properly. Its pistons may create any issues. Its carburetor can also create some issues. Maybe there is some junk uh, attached in the pipe, due to which the petrol is not being fed to the machine and the engine does not run properly. So there can be different issues, and those issues can only be solved until and unless the person does not go to the workshop and gives it to the mechanic that please have a look on the car overall and check whether the each part is working properly or not. So this is basically calibration. And when calibration is not done, you always face errors which we call as systematic errors. So I hope this is clear to you now.
Yes, it's clear.
Instrumental error, basically this was instrumental error. And the second type of systematic error is personal error. Now personal error can be due to the issues done by the person who is doing the experiment. That can be in different ways. For example, he can he is not experienced enough to operate the device. He is not aware that how does the machine work, or maybe he has not doing the setting of that apparatus properly. Maybe he is missing something there. Some part is not in operation, some part is not being fit in properly, so that will cause personal errors to that person. Moreover, he may not be following the guidelines, he may not be following the protocols mentioned in the manual of the device. So all these are the errors caused by the person who is operating the machine, so they are all in the category of personal errors. Is it correct? Is it right? Now
Yes,
is it clear to you? Okay, so
yes,
this was the definition for these two. In you can see on page number 11 in the second paragraph, there is a there is a paragraph in which he is saying systematic errors can be minimized. Now you can see he is telling you how can you correct those errors or how can you minimize those errors. So can you tell me how can the question come in the exam as far as this paragraph is concerned?
what are personal errors, or
Yes, uh,
like
he
he
can
may
ask.
bring what is.
But if we um, more specifically look into this paragraph, we can see he is telling us the procedure to minimize these systematic errors. So he will ask in the question in the exam that how can we reduce systematic errors? Or how can we minimize the systematic error? So you can write a question on this on the top of this paragraph that how can we minimize systematic errors? Please write this question so that you must be aware of the possibility of this question.
Okay, sir.
The answer would start from the systematic errors and end at the end of the paragraph to the readings. Now, if we can read this paragraph, he says it can be minimized by improving the experimental techniques. As I told you earlier, that maybe the person is not doing the experimental procedure correctly. He is not experienced enough to follow the procedure. So the experimental techniques must be improved. Moreover, better instruments should be selected. Maybe the device is not fair enough. It is not of that high quality. So the quality of the instrument should also be improved. Moreover, the personal biasing should also be removed. What is personal bias? Personal bias is means that if a person is doing the experiment in carelessness, or he is not very much concerned about the procedure, he is not very much interested in the procedure, this is biasness. In our daily life we use this word bias. This biasness means when a thing is not neutral, when a procedure is not neutral on the, it is not equal on the both sides, we say it is biased, right? So
Yes.
personal bias means that person has to be very much fair and he should be neutral enough to carry out the procedure. So these are the procedures, these are the steps through which we can minimize systematic error. As far as the last line is concerned, he says these errors may be estimated to a certain extent and the necessary corrections may be applied to the readings. So he says they should be applied. These methods should be applied. So is it clear to you?
Yes,
Systematic.
sir. It is. Yes, sir. It's clear.
Okay. So we will stop here and we will continue from random errors tomorrow, inshallah.
Inshallah.
Let's move on to chemistry now. Page number 11. Today we are going to start a new topic named as limiting and non-limiting reactants. So basically limiting reactant is actually any reactant which is completely used in a process. In a chemical reaction, when we do a chemical reaction, if the reactant being used is completely used, if it is completely uh, wasted, or you can say used, then that reactant is known as limiting reactant. For example, if I say that I mix hydrogen and oxygen to form water, if I say that I started with maybe 50 50 grams of hydrogen, if at the end of the reaction I am left with no hydrogen at all the 50 grams are consumed in this reaction, then I will say hydrogen is the limiting reactant in this reaction. Okay.
Okay.
Moreover, the reactant which is left unused or unreacted after completing the reaction is called Reactant in excess, for example, oxygen. I started with 60 grams of oxygen and only 5 grams of oxygen is being used while the rest of 55 grams is left unreacted, then I will call oxygen as excess reactant, okay, or
Yes.
non-limiting reactant. This is limiting because it is used completely, and this is non-limiting reactant or reactant in excess. Why? Because used less or left unreacted. Have you got the point?
Yeah. Sir, your voice is not audible.
I'm not speaking, I'm waiting for you to write this.
Oh, yeah, I have done it.
Oh. Okay, so let's move on to an example in order to clarify this entire concept. The example is given that 10 moles of hydrogen and 7 moles of oxygen were reacted to produce H2O. Which one of the reactant is the limiting reactant? Now we will first of all write the equation. 2 moles of hydrogen plus 1 mole of oxygen gives 2 moles of water. So he says that 10 moles of hydrogen were used and 7 moles of oxygen were used and we got water. Now I will tell you the procedure that how can we identify the limiting reactant in a chemical reaction with the help of this example, okay? So basically, first of all, you need to be very much clear about this concept that either this will be the limiting reactant or this will be the limiting reactant, because as the name suggests, it is reactant and reactants are only the ones which are on the left hand side of a chemical reaction, right?
Yes.
So again, we will do the same procedure which we have been doing since the start of this chapter, that is stoichiometry, with the help of the procedure which is easy for you, ratio method. We will first of all compare hydrogen with water. Let me tell you the procedure. We will compare hydrogen and water if we got, and then we will compare oxygen with water. If the number of moles of the water produced using hydrogen are less than oxygen, hydrogen will be limiting reactant. And if the opposite occurs, that is the number of moles of water are less when we use oxygen, then the number of moles when we use hydrogen, then oxygen will be limiting reactant, and the other will obviously become reactant in excess. Are you clear about this?
Yes.
Okay. So hydrogen ratio water. As per chemical equation, how many moles of hydrogen are there?
Then, sorry, two.
2 moles. And water,
One,
is it 1?
also two.
Water.
Two.
2, H2O. Okay. And in the question he has given us 10 moles of hydrogen, so I will write 10 here. And what
And
about
seven water.
H2OX? Because we don't know. We will cross multiply. 2x is equals to 20. X is equals to 20 by 2, which is 10 moles of water. So we got 10 moles of water using 10 moles of oxygen, right?
Yes.
Hydrogen, sorry. Now we will do the same procedure for oxygen as well. Oxygen ratio water. Can you tell me how many moles of oxygen are there?
One
1. And water?
for water, two.
2. And what about moles of oxygen given in the
We
question?
don't know.
In question you can see there is he is
For
mentioned.
oxygen, 7 moles of
Yes,
oxygen.
7 moles of oxygen, and we don't know about this one. Cross multiplying will give us 7 twos are 14 moles of water. So can you tell me which reactant is giving us less number of moles of water?
Hydrogen.
Very good. So we will say that since hydrogen produces least number of moles of water, so hydrogen is a limiting reactant. Is it clear to you?
Yes, sir. I did it all.
Okay, can you tell me what is the status of oxygen? What do we call it?
I didn't understand.
I mean, if we say hydrogen is limiting reactant here, and then what about oxygen?
It
What
is
do we call?
non-limiting.
Yes, it is non-limiting, or there was another name, reactant in excess. Okay,
Okay.
you must have written.
Yes, I did read it.
Okay, so hydrogen is limiting reactant, oxygen is non-limiting, or reactant in excess. Fair enough. So let's move on to example 1.6. This is a lengthy one and important. So let's do this. Have you written this one?
Yeah.
So first of all, we should write the equation. Then we can read K2Cr2O7 plus 4 moles of sulfuric acid gives K2SO4 plus Cr2SO4 whole thrice plus 4 moles of water followed by 3 moles of oxygen. In the question, he says 200 gram of potassium dichromate. The name is potassium dichromate. You can write so that you should know the name as well. This is the name of K2Cr2O7, and you know the name of this one, right? What do we
Yes.
call it?
Potassium.
No, no, this one, H2SO4.
Uh, it's sulfur dioxide.
Sulfuric acid, okay?
Sorry, sulfuric
Sulfur
acid.
dioxide is SO2, SO3 is sulfur trioxide, H2SO3 is sulfurous acid, and H2SO4 is sulfuric acid. Okay, so and what about this one? Can you tell me the name of this?
Potassium sulfide.
Potassium sulfate. Okay,
Sulfate. Okay.
sulfate. Sulfite is K2SO3. Since this is O4, whenever remember when you have SO4, you will call sulfate. Okay, so it
Okay.
is potassium sulfate. And what about this one?
Which one?
This second.